Welcome back to Maths Playground. Now that we've covered a few subjects, we're going to start on some random questions. So our first question, there are 100 lights all off, and there are 100 people in a line. The nth person in the line flips every nth switch. After all the people finish, which lights will be on? So, this is like a factor question. Like the second person, let's say the n is 2. So the second person in line will flip every second switch. So, so we're going to try to find a pattern here. So let's start by the numbers from 1 to 10. So we're going to make these this chart so we can notice a pattern. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 1 has just one factor. 2 has 1 and 2, which is 2 factors. 3 has 1 and 3, 2 factors. 4 has 1, 2, and 4, 3 factors. 5 has 1 and 5, 2 factors. 6 has 1, 2, 3, and 6, 4 factors. Let's see, 1, 2, 3, and 6. Yep, 4 factors. 7 has just 1 and 7. We have 2 factors here. 8 has 1, 2, 4, and 8. So that's 4 factors. 9 has 1, 3, and 9, 3 factors. 10 has 1, 1, 2, 5, and 10, which is 4 factors. So notice how the the square numbers like 1, 4, and 9, sorry, not 8, 9 have an odd number of factors. Every other number has an even number of factors. So all of the lights are off right now. So after all the people finish, which lights will be on? So we have off, on, and then off. Every odd number of times the switch has been flipped, the lights are off. So we have to find the number of square numbers we have from 1 to 100 and subtract that from 100 to see which lights will be on. Oh no, sorry. All the lights are off right now. So every even number of times the switch is flipped, that's when the lights will be off. So, opposite way. The number of square numbers from 1 through 100 is how many lights will be on. So we have 1, 4, 9, 16, 25, 25, 36, 49, 64, this is 8 squared, so 9 squared will be 81, and then 100. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 lights will be on. Okay, second question. So we have our rectangle with 3 circles inside it with a radius of 1 each. We have to find the area of rectangle ABCD. Okay, so we might use we're going to have to use the Pythagorean theorem, which states that a squared plus b squared is equal to c squared. In the right angle triangle, where a and b are the two legs and c is the hypotenuse, the longest side. So what we know so far is that the diameter of each circle must be 2 if the radius is 1, which means we know that AB is equal to 4. Okay, now we need to find BC so that we can find the area of rectangle ABCD. So let's use the Pythagorean theorem here. We can make another radius of 1 right here. And then we're going to make a line over here. We know that this little part inside the circle is 1. And now we can make this the hypotenuse, since we know that this is 1 and this is 1, because these both are the radiuses of a circle. So now we're going to apply the Pythagorean theorem, because this is a right angle triangle. So we have 1 squared plus, let's call this part x, this tiny little part, because notice how this part is sort of overlapping in the radius. So we're going to call this part x. We need to find this to find BC. So we have 1 squared plus x plus 1 squared, because we have x over here, plus the radius, which is 1. So plus x plus 1 squared is equal to this part, which is 2 squared, which is equal to 4. So now, since we know that 1 squared is 1, we're going to subtract 1 on both sides. So we have x plus 1 squared is equal to 3. Okay, so since we need just x, how about we square root on both sides? We end up with x plus 1 is equal to square root of 3. So now let's subtract 1 on both sides. We have x is equal to square root of 3 minus 1. Okay, now to find BC, we know that this part is 1, since this is the same as the radius of the circle. So we have this one plus this one, 2, and then 3. So we have so we need to find BC. So BC is equal to square root of 3 minus 1 plus 3. So we end up with 2 plus square root of 3. Challenge time. Since we know that AB is 4 and BC is 2 plus square root of 3, how about you try to find the area of rectangle ABCD? Okay, third and last question for now. So we have to find the area of the blue square, and we have two circles above it with radius of 5 centimeters each. So here again, if we use the Pythagorean theorem, we can make a little triangle over here. This should be easy since we know that this is 5 since this line is the radius. If we call one side of the square x, that means this would be x2, and since this is a radius of 5 centimeters, we have 5 minus x for this side, and we can call the bottom side y. Okay, so now let's use an equation. We can use the Pythagorean theorem again. We have 5 minus x squared plus y squared is equal to 25. Then let's open the parentheses. We have 25. So we have a minus b squared, which is a squared minus 2ab plus b squared. Okay, so we have a squared minus 10x plus x squared plus y squared is equal to 25. We have 25. 25, we can cross those out. And we're left with x squared minus 10x is equal to negative y squared. So if we multiply by negative 1 on both sides, we end up with 10x minus x squared is equal to y squared. Now let's square it on both sides. So we have y is equal to square root of 10 minus x squared. Okay, so now to make an equation, let's find another equation for y. If we make a line here, then we make another line over here. This is also equal to y. So we also know that 2y plus x is equal to 10. Okay, so what can we do with this? Since we need to find y, we can turn this into 2y is equal to 10 minus x. So now let's divide by 2. We have y is equal to 10 minus x divided by 2. Okay, so we have one equation for y here and another equation for y right here. So now let's solve that. Then we know that square root of 10x minus x squared is equal to 10 minus x divided by 2. Let's square on both sides. We end with 10x minus x squared is equal to square of 10 minus x divided by 4. Let's multiply by 4 on both sides to get out of fraction land. So we end up with 40x minus 4x squared is equal to 10 minus x whole square. Okay, so we can turn this into 40x minus 4x squared is equal to 100 minus 20x plus x squared, right? So now let's do 40x plus 20x is equal to 5x squared plus 100. Okay, so now let's turn this into a quadratic equation. We have 5x squared minus 60x plus 100 is equal to 0. Now let's divide by 5 on both sides to simplify this. We're going to start up here. So we have x squared minus 12x plus 20 is equal to 0. So then we have x squared minus 2x minus 10x plus 20 is equal to 0, right? Okay, so now let's factor this out. So let's factor out x on this side. So x times x minus 2 minus 10 times x minus 2 is equal to 0. Okay, so now let's turn this into x minus 2 times x minus 10 is equal to 0. So since this is equal to 0, and we know that both of these can't be equal to 0, then either x is equal to 2 to make x minus 2 0, or x is equal to 10 to make x minus 10 0. So obviously x can't be equal to 10 because from here 10 would be all the way up to here, because if 5 centimeters is the radius, 10 centimeters must be the diameter. So obviously x has to be equal to 2, which gives us the area of the blue square, which would be 2 squared, which is equal to 4. Long? This is a long question, but it's super interesting too.